Ladies and gentlemen, please welcome President, Products and Technologies, Paul Cormier.
Wow. You know, like Jim said last night, the 10th summit. Boy, if this doesn't get your adrenaline going, you're dead. How do you not get psyched over this? Look at, unbelievable. You know, over the 10 years, it's just been and continues to be an amazing journey. It's such an exciting time for open source software. And even in the last year, so much has been done just since the last year. Really, Linux and open source software has continued the pace of innovation like never before. It's about innovation. That's what this is about. And this is something that's just never happened before. And you know, in some way, and I say this every day, everyone in this room, we're all lucky to be in the middle of this. This is a once-in-a-career lifetime to be able to be in the middle of something that literally is changing the world, changing the way that we compute, that we do computing. You know, I'm going to talk about that today. I'm going to talk about the amazing technology developments that are based on Linux that has enabled all of this over the last 10 to 12 years. I'm going to bring that all the way back. Linux has been building the platforms for which has powered all this innovation in open source software, and it's all been powered by Linux, and that's what's bringing us to the cloud today. It's focusing on all facets of cloud development. Linux is at the heart of it. You know, as we did with Red Hat 12 plus years ago, we're moving all these technologies out to our customer base as well, across the infrastructure. We're all witnessing this firsthand right now in this transformation. Linux and open source software is changing all the rules that the proprietary guys set over 40 years ago. That's the fun part. The introduction of open source software is quickly expanding to the entire infrastructure, and that rate of change is just accelerating every day. It really is from Linux to middleware to OpenStack to platform as a service to software-defined networking, software-defined storage such as projects like Gluster and Ceph and Hadoop. It's all built on open source and all built with Linux as the foundation. What we do is we bring those technologies and solutions to our customer base. We make it consumable, and that's the strength of what's going on here today. And everybody in this room is a critical part of that process. That's the strength. It's this room. If I look back 10 years ago and I look at this room, it was like a group meeting. You look at this now and you look at the people here, that's what's driving this change. You know, but there's been so much confusion over the last 10 to 12 years of what the role of the operating system is in the next generation architecture. This is one of my favorite quotes. Some have even said out there that the OS was dead. This was a real quote from a few years ago from a former CEO of the leading virtualization company. I think we all know who I'm talking about. What I'm going to show you over the next 30 minutes or so, I want to come back to that and let's see how this really played out over the last 10 years and where it's going. Linux has become so central to the data center. It's in the enterprise today, and what it's really driving is that convergence of physical, virtual, private, and public cloud. It's creating one seamless environment for the application. The app is king. You got to remember that. This is all about the application, and it's always been about the application. It's all about running that application with consistency across the data center, and that's where the operating system comes in. RHEL was the beginning of that transformation. It was really the beginning of bringing Red Hat and Linux into the data center. RHEL gave users a stable, open, commercial-grade platform to get free of the lock-in of the proprietary guys. That's what RHEL brought into the data center. It was the beginning of Linux as the foundation to build that next-generation infrastructure. And it really brought Linux to the commercial masses. It brought the application developers, the ISVs, and the CIOs an open, high-performance, stable, and secure platform to build and run their commercial critical applications. It's all about the application. And RHEL's going to bring that to the next level, and we're going to talk about that today. You'll see that all this week. RHEL has now become one of the two main commercial-grade OSs in the data center, along with Windows. It's key, along with Windows. In the beginning of the RHEL journey, there was so much talk from both sides of Windows, Linux. Now, I think even from a Microsoft perspective, it's RHEL and Windows in the data center. There's no argument. RHEL's built an ecosystem over the last 10+ years that's certified every major hardware, software ISVs that the customers had running across the data center. That was one of the strengths of RHEL, and to get this into the data center, to make it easy for our customers to move to a Linux platform. Customers in every major vertical, from banking to media, started to transform their data center with Linux and with RHEL. Linux and RHEL gave them that platform with the freedom to consume the best innovation for the application to run their business. It was developed by an open community, and it's not dictated to by one company. This changed the game forever, and that's what's really driving this today. The first thing that was really interesting that happened once we started to get Linux and open technologies into the data center was the app became decoupled from the hardware. It brings much benefit to decouple that. Actually, the proprietary guys had been working on this for some time. One proprietary company got there first and brought a lot of functionality to the customer, a lot of benefit to the customer, but they just couldn't resist the lock-in model of the 80s, and they didn't have an OS to run the app. Linux and the open source community responded to this. They saw a need, they assembled, they started to work, they developed, and because Linux was an open platform and virtualization was solving real problems, innovation just took off from there. That was really one of the big hockey stick moments in this. Virtualization was and continues to be developed as an integrated part of the Linux operating system, instead of a separate layer like the proprietary guys. That brings so much value to this. It brings so much. It brought an even better virtualization solution to the market. Virtualization developed in lockstep as part of the Linux development effort. This is really the power of the open source model. Communities got together. The open source development community responded. You know, having an OS platform that now decouples the app from the hardware while maintaining a stable, open, performant environment and bringing the benefits of the ecosystem with it brought computing to a whole new level. This was really the beginning. With Linux now fully in the mainstream, the power of the open source model now started to work on services needed to build enterprise-class apps. Started in an open methodology. This had previously been controlled completely by the proprietary world, this layer of the middleware stack in building applications. From OpenJDK to the app server to services like messaging, data caching, rules engines, services like that, those were all critical to really get this started. With Linux now fully in the mainstream, the open source model really started to work. The power of the open source model started to work in really in a main way here. This was all, as I said, previously controlled by the proprietary guys. The middleware layer was fully opened up at this point. This brought us from a vertical proprietary app way to communicate within applications to a horizontal model which takes us across the entire data center. And because this all plugged in and integrates to an open operating system, huge leaps were made in performance, security, etc., all with open communities, because open communities were working together. RHEL 7 brings even more collaboration across these open development communities to bring not only OpenJDK and middleware into the equation, but also it's now the best solution for the applications on a completely open model platform. The combination of decoupling the app from the hardware in a completely open middleware stack extends the mobility, performance, and stability for middleware-based applications. That was only possible in the closed world of the past. It's another inflection point of really where we went here. But you know, at this point, as open source started to solve even more problems, Linux was now enabling some of the biggest and innovative new services out there. Services like Google, Facebook, Amazon, virtually every cloud provider, Linux enabled them to even exist. They couldn't be here without Linux. They're all built and powered on Linux, and they depended on the elasticity, on the application elasticity, to run these new businesses. One of the things that came out of this was, again, open source solving the problem, was starting to think about abstracting the main services of compute, storage, and networking now from everything. This was the way for these new services to get that elasticity needed for their applications. These next-gen companies started the development of many of these new features for their own needs. But because they were able to do this, because they were built on open technologies, and they were built on technologies that were completely available to them. This just couldn't have happened in the past. It was all developed on Linux. And as companies started to see what the Googles, the Facebooks, the Amazons, the cloud companies were doing, as companies started to see the benefit of that, as they started to see the ratio of administrator to server out there, companies wanted to take advantage of this to run in their own environments. The OpenStack project was started with much of this in mind. OpenStack is, as most other projects in the infrastructure, it's developed on Linux, with Linux, by extending Linux. OpenStack's dependent on Linux. Yes, it'll run everywhere, but it is very dependent on Linux and goes in lockstep with Linux. The power of open source development once again at work. And why? This just could not have been done in a proprietary model. Couldn't have been done by one, by two, or even three companies. It's just too big a problem to be solved by one company in their labs. And that's why we're at where we're at today. The platform for the enterprise to give their apps this elasticity and the benefits of this abstraction and elasticity that the Googles, Facebooks, and Amazons run. That's what OpenStack brought to the table. They run their services on this, but it's under their control. This is the private and public cloud. It's all built on Linux and OpenStack, and this is what's powering the private and public clouds of today and tomorrow. With this, we started to look at things, the community started to look at things. Applications now need portability across physical, virtual, private, and public clouds. As companies started to move each one of these footprints into their environments, they now depend on that portability. They can't get locked into one stack. How do they get that portability? The app still needs stability and predictability from the operating system in order to accomplish this. While becoming elastic and mobile, Linux still continues to dominate the innovation around this at the same time. By effectively splitting the OS, with the app linking to part of the OS, and with another half of the app linking to a host, this is where the container has been born. Container technology's been around for a while, but now, over the last few years, being developed within Linux, it's gone much faster, much more innovative, and this is one of the things that's really going to drive the future. That container, though, still needs to be certified and run on a host kernel. It's almost more critical now when I have a part of the operating system with the application to know what I am running for a host, to know that stable platform that I'm running as a host. You're going to see us announce today a new RHEL atomic host as part of the RHEL family. We're bringing this out as a platform to run containers all the way across. This is going to be one of the main technology advancements of RHEL 7. You'll hear much more about this from me today at the summit and in the future. With this, now multiple containers can share the common host services such as security, identity, network, and storage, while still extending that RHEL ecosystem that's been 10 to 12 years in the making across this next generation operating system with containers from day one. So like RHEL, where we put an on-ramp with an ecosystem for our customers to get on the Linux platform, we now bring that to the same level with that ecosystem to bring them across containers, built on RHEL, the same ecosystem. This now lets the application consume enough of the OS for the app to focus on portability across that physical, virtual, private, and public cloud, while certifying the part of the OS that contains that common services. So you know how that app's going to perform. You can count on that app performing. You can count on that app having the security needed across all of those environments. This is where the innovation of Linux has taken us to this point, and it continues to go. But that portability of the app, it really doesn't matter without the platform consistency. And this is what RHEL 7 brings to the table, all the way across and out to the cloud. Who would have imagined that 10 years ago when we started this? With the app now certified on the platform, that same certified platform can run across the entire hybrid environment, all powered by the evolution of Linux. With elasticity capabilities now built across the OS, coupled with OpenStack services, it now all needs to be controlled. How do I control that elasticity? But that control needs to be put in the hands of the application. This is where the PaaS platform, the PaaS, Platform as a Service platform, comes in. With tight interaction with the OS and containers, this is what makes it all happen. More containers, more density, more elasticity, more coordination that's needed. PaaS increases this new capability from an application viewpoint. You hear us talking so much about the application now because that's what it's about. With PaaS, the developer defines the application and uses the containers to compose it. This is the next generation of application development, built together. With PaaS now being used to build the enterprise apps, the enterprise class services that have driven those enterprise apps for years are needed. Now that enterprise class developers are coming to the table and building on a PaaS platform, they're saying, I have an enterprise class app. I need messaging. I need data caching. I need rules engines. How do we bring that into the equation? This is what XPaaS is all about. Combining the JBoss services that the community's been developing over the last 7, 8, 9 years, that's what building enterprise apps are all about. Bringing those into the PaaS platform is what XPaaS is all about. This is how it comes together. The open source innovation of years of Linux with years of open source middleware innovation of JBoss, they come together to build a truly hybrid environment for the application, for the development of the next generation enterprise application. We're talking about the next generation, but we're here now. This is what's happening now. The app development platform and the infrastructure come together as one for an app platform that spans all the way out to the cloud. As the public cloud now becomes part of that enterprise environment, apps need to communicate. It needs to be one seamless environment. A common, stable application, a platform across physical, virtual, private, and public cloud with enterprise class services across a common storage namespace, managed by a single pane of glass tying this together with the capabilities that emanate out from the operating system, all the way out to the public cloud. This is what the first 5 releases of RHEL were setting the stage at. We're now at RHEL 7, and now we're delivering on that. This has all been built with the open source development model. This is what Open Hybrid Cloud is all about. This is Open Hybrid Cloud in practice across all of this. I go all the way back to that quote that I started in the beginning of this talk on. Seems like a long time ago, at least for me. Go all the way back on that. You know, maybe he was correct, but he certainly wasn't anticipating the power of the open source model. How could he have? He couldn't have been talking about Linux, because look where we are today. With the power of the open source development model, Linux has evolved to be the OS to the cloud. RHEL 2.1, it was about a stable platform for the app, a stable platform to bring the app into the data center. And RHEL 7 is about take that stable platform, taking the application all the way out to the cloud. The app has been and is still king. The operating system is the heartbeat that continues to beat, and it gets stronger and stronger and stronger, all driven by open source software. This is the future. It's now. It's open. Enjoy it. Drive it. We're going to change this world starting today. Have a great time at the summit.